Welcome back to All This Math. This is Professor Parker. And shout out to Clark Atlanta University down in Atlanta, down in the Atlanta University Center, down there with Morehouse, Spelman, Morris Brown, the Interdenominational Theological Center, and just Atlanta in general. For today's lesson, we're going to talk about how to solve double absolute value inequalities. Sometimes we talk about solving double absolute value equations, but right about now, we're going to talk about how to solve double absolute value inequalities. See the inequality symbol right there, the greater than sign? All right. So we solve these similar to the way that we solve double absolute value equations. We first got to find our turning points, right? The turning points are the values for x that's going to make this expression in the absolute value equal to 0. All right. And also here. So we set up two equations. We do x minus 3 equals 0. And we do 2x minus 5 equals 0. That's going to be our first step. All right, so let's do that. Let's find our turning points. So we got x minus 3 equals 0. And if you add 3 on both sides of the equation, you get x equals positive 3. So that's one of our turning points. And we use the turning points in our table. I should have said that also. We're using the table of intervals method. Table of intervals method. We use these to know where to separate our intervals at. All right, so this one, 2x minus 5 equals 0. We're going to add 5 on both sides. It gives us 2x equals 5. Then we divide by 2 on both sides. It gives us x equals 5 halves. So these are our two turning points, 3 and 5 halves. And this is solving these is like a 5/6 step process. That's the first step right there. All right, so we do these problems one step at a time. Don't get overwhelmed. Just think about the steps and then do them one step at a time. Once you know the steps and you know how to interpret the steps and know how to proceed after each step, just do the steps one step at a time. You'll get to the right answer every time. All right, so first step, find the turning points. Then you set up your table. Now, because we got two turning points, our table's gonna have 3 intervals. 2 turning points, 3 intervals. Because we're going from negative infinity to the smallest turning point. Then we're going from the smallest turning point to the next biggest turning point. And then we're going from the next biggest turning point to positive infinity. That's what's going to happen here. I'm going to show you what it's going to look like. I'm going to draw my table right here. Negative infinity to now, what's bigger, 3 or 5 halves? 5 halves is the same thing as 2.5 or 2.5, right? So 5 halves is smaller. So we go from negative infinity to 5 halves. Then we go from 5 halves. Now notice what I do. I include the 5 halves in this interval. I go from 5 halves to 3. And then in the next interval, I include this leftmost point. So I include the 3. So I go from 3 to infinity. All right? So now that's step 2. I set up my table. I got my table set up. I'm cool. I got my table set up. I got my 3 intervals, 1, 2, 3. The next step, which we could consider our third step, is to test out our absolute value expressions. When I say test them out, that means that within each interval, right, we pick a value that's within each interval, and then we test out the expression to see if we're going to end up with a negative or a non-negative value. A negative or a non-negative value. Again, we testing out the expressions inside the absolute value to see if we're going to end up with a negative or a non-negative value. If we end up with a negative, that means that in our equations that we're going to create, well, actually, no, not equations. Our inequalities that we're going to create, we're going to take the opposite of the expression, meaning we're going to make it a negative. If we end up with a non-negative, meaning a 0 or positive, 0 or positive, 0 or positive is non-negative, then that means that we're going to keep the expression exactly the way it is in our inequality that we're going to do in our next step. So check this out. I pick a value that's between negative infinity and 5 halves. 0's in between that, in that interval. 0 is always easy to work with. So I throw 0 in here. 0 minus 3 is a negative 3. So that means that when I use a number from this interval, this expression is going to be negative. So that means that in my inequality that I'm about to set up, I'm going to use the expression negative x minus 3. Negative quantity x minus 3. And I write that down. That's the purpose of this table, is to write down your expressions. So you'll see within the intervals what they're going to look like. All right. Then I do the same thing with 2x minus 5. 2 times 0 is 0. 0 minus 5 is negative 5. We get another negative. So that means that expression is going to be negative also in this inequality. because each of these intervals is going to have its own inequality. We're going to have to solve this inequality 3 different times. And then we're going to have to test our solutions to see whether we're going to accept them or reject them. We're going to see if we're going to accept or reject the deposit, like Tupac on Against All Odds. All right? You know what I mean? So we got negative quantity 2x minus 5. All right, then we go to this interval. What's between 5 halves and 3? That's kind of a tight interval because 5 halves is 2.5 and 3 is 3. But 5 halves is included, so we could just just use 5 halves. So what's 5 halves minus 3? That's 2.5 minus 3. That's a negative. So I'm gonna make this negative x minus 3. And then I'm gonna use 5 halves again. 5 halves times 2, that's easy because the 2 is gonna cancel out, leaving me with a 5. And then 5 minus 5 is 0. So that's a non-negative. So if you get a non-negative or a positive, that means you keep the expression just the way it is. Remember that. If you get a non-negative, meaning a 0 or a positive, when you take a number from the interval, throw it into the absolute value expression, test it out. If you get a 0 or a positive, that means you're going to keep the expression the way it is. So I'm going to just use 2x minus 5. Then we go to this interval, from 3 to infinity. From 3 to infinity. I could just use 3 for real. So, because 3 is included because of my bracket. So 3 minus 3 is 0. So again, we got a non-negative. So that means I keep the expression the way it is. X minus 3. And then I go to this expression. 2 times 3 is 6. 6 minus 5 is 1. That's positive 1. So because we got a positive, we're going to keep the expression the way it is. 2x minus 5. Now it's time to set up our 3 separate inequalities and solve them. So my first inequality is based on this interval. My second inequality is based on this interval. My third inequality is based on this interval. So my first inequality is going to look like this. I'm going to label it letter A. Negative quantity x minus 3 is greater than negative quantity 2x minus 5. All right. Negative quantity x minus 3 is greater than negative quantity 2x minus 5. What I'm going to do is I'm going to distribute these negative ones. These negative signs are really negative ones. So I'm going to distribute them. So I got negative x plus 3 is greater than negative 2x plus 5. All right. Now I'm going to add 2x on both sides. Add 2x on both sides because I got too many x's. Negative x plus 2x is x. So I got x plus 3 is greater than 5. I'm going to subtract 3 on the left, subtract 3 on the right. 3 and 3, I got x is greater than 2. So x is greater than 2. So now I got to go back into the interval to see if I'm going to accept or reject this, right? So x is greater than 2. Now here we got negative infinity to 5 halves. All right. So now x is greater than 2. So we go from negative infinity. But that means that all the values in this interval from negative infinity up to 2, we reject them. We reject them. We only keep the values between 2 and 5 halves. 2 and 5 halves. All right. So we're going to say, let's say from 2 is less than x, which is less than 5 halves. All right. Now I want you to think about what I just said, because this is an inequality. So we do a little bit different than how we do the equations, because the equations give us one solution or one number, right? Usually. So we just go into the interval and see if that one number is in the interval. But with inequalities, we got to look at what we get, because this means that x is greater than 2. That means any number bigger than 2 is a solution. So 3 is a solution, 4, 5, 6, 7, 8, 10 million, 8 trillion, 6.9. Those are all solutions. But look at this interval. This interval goes from negative infinity all the way to 5 halves and stops there, right? But this says that x is greater than 2. So that means that we're only concerned with the values that are actually greater than 2, but are also in this interval. Greater than 2, but are also in this interval. Greater than 2, but also in this interval. So going from 2 to 5 halves. So remember, 5 halves is just 2.5. So basically all the values that's between 2 and 2.5, all right, in this interval. Now, let's set up an inequality for this one. Letter B. So we got negative quantity x minus 3 is greater than 2x minus 5. So distribute the negative 1, because that negative sign is really a negative 1, right? So we got negative x plus 3 is greater than 2x minus 5. So we're going to do minus 2x on the right and minus 2x on the left. They cancel out. That's negative 3x plus 3 is greater than negative 5. Then we're going to subtract 3 and subtract 3. 3's cancel out. Negative 3x is greater than negative 8. We're going to divide by negative 3. Divide by negative 3. Oh, don't forget. When you're dealing with inequalities and you divide by a negative on both sides, don't forget to flip that inequality sign. Don't forget that. It's a very common mistake. Don't fall for it. Don't forget it, I mean. It's not really like you falling for something. Flip it around. Now you got x is less than, and we got 8/3. So x is less than 8/3. 8/3 is the same thing as 2 and 2/3. 2 and 2/3. 2 and 2/3. Now, but this interval goes from 2.5 to 3. 2.5 to 3. So that means that we're concerned with all the values that are less than 8/3, but are also between 5/2 and 3. So that means that now we know that 8/3 is bigger than 5/2. So 8/3 is somewhere in between 5/2 and 3. So that means that this is going to be 5/2 is less than or equal to, because 5/2 is included. 5/2 is included, so it's less than or equal to x, which is less than 8/3. Because 8/3 is bigger than 5/2. So again, we want all the numbers that are less than 8/3, but also in this interval. Less than 8/3, but also in this interval. Less than 8/3, but also in this interval. So where they at? They between 5/2 and 8/3. Because 8/3 is bigger than 5/2. 5/2 is 2.5. 8/3 is 2 and 2/3. 2/3 is more than a half. 2/3 is like 67 cents. A half is like 50 cents. 67 cents is more than 50 cents. So use use money as a frame of reference to get a better understanding. All right, let's do our third inequality. Third inequality, we got x minus 3 is greater than 2x minus 5. I gotta hurry up because I gotta take a cider to get our hair done. Let me hurry up with this joint. So x minus 3 is greater than 2x minus 5. So we're gonna do minus 2x on the right, minus 2x on the left. Boom, x minus 2x is negative x minus 3 is greater than negative 5. I'm gonna add 3 on the left, I'm gonna add 3 on the right. Boom, boom, negative x is greater than negative 2. Don't forget to get rid of this negative sign, but if you do that, don't forget, flip that inequality, flipping. All right, so we divide by negative 1, divide by negative 1. You got x is less than positive 2. X is less than positive 2. So look at this interval. This interval goes from positive 3 to infinity. Numbers less than 2 is not even in this interval. It's not even in this interval. So we put an X right here because this interval isn't even valid for this problem, for this particular inequality. So now let's write our answer. But let's look at what we got though. We got two solutions right here. X is between 2 and 5/2, and X is also greater than or equal to 5/2, but less than 8/3. So since we got 5/2 as a boundary point for each of these, we could basically just combine these two. We could just combine these two, right? And we could just say that X is greater than 2, but also less than 8/3. So that means that if you're looking for the solution to this inequality, it's going to make it a true statement. It's going to make the left side greater than the right side, right? And this absolute value, double absolute value inequality. Any number that's greater than 2, but less than 2 and 2/3 is going to be a solution. Any number that's greater than 2, but less than 2 and 2/3 is going to be a solution. Try it out. Try it for yourself. All right? Do 2.25. Do 2.5. Do 2.66, because 2.66 is less than 8/3, because 8/3 is 2.67, because 8/3 is 2 and 2/3. All right? And those are the steps. Those are the steps. Now, this video is just a guide, right? Use this video as a guide and go ask your teacher, ask your professor for some more practice problems, because you really learn this from doing practice. I know how to do this from doing practice. All right? You can know how to do this as well from doing practice. That's all you got to do. All you got to do is practice. All right? Practice gets you close to being perfect. You'll probably never be perfect, but even I'm never going to be perfect at this, but you'll get close to being perfect from practice. All right? So go get you some practice, and I'll catch up with you on the next video. All right? Peace.